Welcome all. So I'll take up some of the very good questions from GATE and engineering services examination point of view, maybe for BARC or ISRO. The topic that I'm taking the questions on is theories of failure. Let me take up some very good questions. So I'll take up 3 questions and you'll get a good idea of how the failure theories are applied to some practical questions. Okay. A solid circular shaft, one second please. Okay. A solid circular shaft made of ductile material with a yield stress in tension as 280 megapascal is subjected to a torque of 10 kilonewton meter. Using Tresca failure theory, the smallest radius to avoid the failure is. So let me do this question. Okay. There is a shaft and the shaft is subjected to a torque of 10 kilonewton meter. So I'll write it as 10 power 3 kilo 10 power 3 newton. Meter is 10 power 3 mm. So the torque is nothing but 10 into 10. This is 10 power 3 10 power 3 10 power 6 newton mm, or this can also be written as 10 raised to 7 newton mm. This is the torque. Okay. Now he is asking, according to Tresca's failure theory, what is the minimum radius of the shaft to avoid the failure? Whenever a member is subjected to pure torsion, if you take an element on the surface, we have something like this. This is tau max, this is tau max, this is tau, and this is tau. Okay, no problem at all. Right. Let's try to draw, and what we do is, let's try to find out the maximum shear stress. According to this, the maximum, in this case, if you draw the Moore circle, you will get the maximum shear stress. Okay, let's draw a Moore circle. This is normal stress and this is shear stress. Okay. Look at, the center of Moore circle will lie on sigma x plus sigma y by 2 comma 0. The center of Moore circle will always lie on normal axis, that is x axis. So therefore, because y coordinate is 0, there is no sigma x, there is no, because under pure torsion, there is no sigma x, there is no sigma y. Sigma x plus sigma y by 2 is nothing but 0 plus 0 by 2. Okay. So this will be the center. Let's find out the radius. And the radius is under root of sigma x, there is no sigma x, minus sigma y, there is no sigma y, by 2 whole square plus tau square. So the radius is equal to tau. The center is here and the radius is tau. So this is our Moore circle, and the radius is nothing but this is tau, and this is the major principal stress, this is 2, and this is minor principal stress. So I will write sigma 1 is the major principal stress tau, and sigma 2 is minor principal stress, that is minus tau. The point to be noted here, and sigma 3 is 0. Okay. Always calculate the absolute maximum shear stress. Now, I told you in my earlier classes also, when two principal stresses are of opposite nature and the third is 0, then the maximum, and the maximum shear stress is nothing but it is maximum of, absolute maximum of sigma 1 minus sigma 2 by 2, sigma 2 minus sigma 3 is 0 by 2, and sigma 1 minus sigma 3 is 0 by 2, absolute maximum. Look at carefully. When both are of opposite nature, minus of minus will be plus and this value will be more. I repeat, when both are of opposite nature, the absolute maximum is this one only. For example, I'll give you an example. Let us say sigma 1 is 30, sigma 2 is minus 10. So sigma 2 will be minus 10 by 2, it will be minus 5. Sigma 1 is 30, 30 by 2 is 15. Now what about this? 30 minus of minus is plus, 30 plus 10 is 40, by 2 is 20. So this will be 20 minus 15 minus, so this will be maximum. So therefore, always remember, when two principal stresses are of opposite nature, the maximum will be this. So I write tau maximum is equal to sigma 1 minus sigma 2 by 2. Okay, now what is sigma 1? Tau. What is sigma 2? Minus tau. So therefore, now I write, so maximum shear stress is given by sigma 1 is tau minus sigma 2 is minus tau by 2. So the maximum shear stress is nothing but tau itself only. Very good. Which theory is he asking? Tresca's failure theory. And you know very well, according to Tresca's failure theory, the maximum shear stress according to Tresca theory is half of yield. According to Tresca's theory, the maximum shear is half of yield. And the yield is given as in tension, the yield is 280. Therefore, now this can be written as tau max is equal to 280 by 2, which is nothing but 140 megapascal. Therefore, the maximum shear stress, which is tau, is nothing but maximum shear stress, which is tau, is 140. No issues at all. 140 megapascal. And what is he asking in the problem? And it is subjected to a torque of 10 into 10 power 7. And what is given? He is asking the radius. Okay, fine. And the torque is 10 power 7. Torque is 10 power 7. And the shear stress is 140. You know that when a member is subjected to pure torsion, we have tau is maximum shear from our torsional theory. T by J is equal to tau by R. Tau max is given by 16T by pi d cube. Okay. The maximum shear stress is 140. That is equal to 16. The torque is already, 10 power 7. I repeat, this is megapascal. Megapascal is nothing but Newton per mm square. Means my length dimensions are in mm. 16T. Already I kept this in Newton mm by 16T by pi d cube. Okay. And let me calculate the value. 16 into 1 exponent 7 divided by pi. Okay. Divided by 140. Yes. And I want this value. What is that? Yes. So you are getting D value as 71.38 mm. But I think it is a fill in the blank question. If you see, he's not asking diameter, he's asking radius. So that too in centimeter. And always remember, whenever it is a fill in the blank question, you should take extra care of units. Okay. And he is asking radius and that too in centimeter. But I got the diameter, but not in centimeter. I got in mm. So the diameter is given by 71.38 mm. So if you want radius, radius is half of the diameter. So divide with 2 and you have 35.69 mm. And if you want in centimeter, it will be 3.569. If you are rounding it off, this will be in centimeter. 3.57 centimeter is the diameter. This is the diameter. Is it clear? Very good. Now, please understand things clearly. Now, coming next to two questions are beautiful questions. And coming two questions are very good questions. Let's take up those questions. Read this question. Let me read the question. A solid transmission shaft has a length of 10 meter and diameter of 100 mm. The shaft is supported by frictionless bearings at the ends that act as simple supports. इधर देखो, there is a shaft and it is supported in bearings, and those can be treated as simple supports. The length of the shaft is given 10 meter. Okay. Now, the diameter is also given. Look at carefully. In addition to its self-weight, oh my God, acting as a uniformly distributed load per unit length. In addition, so the shaft, he's asking us to include the weight of this. Because of its weight, it will bend. Okay, I repeat, because of its weight, it will bend. And he clearly said, assume that weight as uniformly distributed throughout its length. Very good. So actually, so what I'm doing is, this is the shaft, it has its own weight spread over the length. Now, he is asking us to treat it as that weight uniformly distributed throughout the length. इसका मतलब अगर shaft negligible weight है, तो this can be treated as uniformly distributed load, or shaft का weight is uniformly spread throughout the length. Okay, the density of the shaft is given as 8,000 kilogram per meter cube. Okay, the yield strength is 350 megapascal. Very good. And using G as 10 meter per second square, ignore the effect of transverse shear. Okay, transverse shear. Okay, the factor of safety as per Tresca theory or maximum shear stress theory. This is also a good question. But he also said, apart from this, it is subjected to a torque of, it is also subjected to a torque of 5 pi kilo Newton meter. Chalo. Let us try to solve this question. Let's try to solve this question. Okay. इसको हम solve करने की कोशिश करेंगे. Chalo. You know, my dear students, when a shaft is subjected to uniformly distributed load, we know that the maximum bending moment is given by, if this is W per unit length, if the uniformly distributed load is W per unit length, the maximum bending moment is given by WL square by 8. Okay, let's calculate W. Can you tell me what is W? It is, first let us calculate, W is weight per unit length, and that weight is uniformly distributed throughout the length. If you know, my dear friends, density is equal to mass over volume, or mass is equal to density into volume, or weight is equal to mg, total weight of that shaft, or weight per unit length is your small w. Weight per unit length. So therefore, weight per unit length is small w. Already you know weight. What is that weight? देखो weight क्या है? mg. Weight is mg. Weight per unit length. Okay. But m is equal to rho v. So small w is equal to small w mg by l. But what is m? What is m? M is rho v. This m can be written as rho v. Okay. M. Small w is m is rho v into g by l. Very good. So, but you know that volume can be written as area into length. Okay. This volume can be written as AL by L. Okay, no problem at all. So therefore, weight per unit length is given by rho G into A. So let's calculate weight per unit. The density is given, I think, as 8,000 if I'm not wrong. Yes, it is 8,000. And he's asking us to take G as 10. The area, pi, it is circular in shape. So therefore, pi by 4, 0.1. Let me take the 100 mm is 0.1 square. The unit of this will be weight per unit length, because I have taken length dimensions in meter. So let me calculate 0.01 into pi into 81234 by 4. 1 second please. 0.01 into exponent by 4 into 8123. 62 point rho GL. So what is the density? Let me check. 8,000 है ना? Okay. So 8,000. So this will be let me check once again. 8,000 into 10 into pi into 0.01 by 4, and this will be 628.32 Newton per meter. This is W per unit length. This is W per unit length. Okay, no problem at all. Yeah, this is W. Let's calculate the maximum bending moment. Whenever the shaft is subjected to uniformly distributed load throughout the length, the maximum bending moment for simply supported load, the maximum bending moment is given by WL square by 8. Please take care of units. W, what is W? 628.32. The unit is Newton meter. L, the length is given as 10, so 10 square, length square is meter square by 8. So this you get it in Newton meter. So 628.32, and I request everyone to calculate. Yes, this will be 7854. Take care of unit. So Newton meter, or this can be written as, okay, I got bending moment, that is the maximum bending moment. So let us calculate the maximum bending stress. The maximum bending stress is given by M by I is equal to sigma by My by I. So sigma maximum is given by M. Already you know, N 7854. 7854 into 10 power 3. It was in Newton meter. I'll convert it into Newton mm. Why? What is the diameter? The diameter is given as 100 mm. So therefore it will be, Y will be 50, because if this is the shaft and from the center the maximum value, the Y is 100 hai to ye 50 mm hoga. Okay, by I. For circular section, I is pi by 64, diameter is 100 power 4. This is Newton mm, this is mm, this is mm power 4. So you will get this in Newton. This is Newton per mm square, which is megapascal. Let me calculate. Into 50, okay, divided by, so I am getting this as 80 megapascal. Clearly, he also said in the problem, it is subjected to a torque of 5 pi kilonewton meter. So the torque is given as 5 pi kilonewton meter. So I will write this as 5 pi. Kilo means 10 power 3. Meter is 10 power 3. This will be in Newton mm. Okay. And the maximum shear stress because of the torque is given by, from my fundamental equations, 16T by pi d cube. 16. The torque is 5 pi into 10 power 6. This is 10 power 6 by pi d cube. I think the diameter is given as 100 power 3. Let's check the unit. Torque is taken in Newton mm. because from Newton meter I converted, and d cube is mm cube. So this will be in Newton per mm square. Newton per mm square is nothing but megapascal. So pi is gone. 100 power 3 is 10 power 6. 10 power 6. 16 5s, it is 80. The maximum shear stress is 80 megapascal. Actually, my member is subjected to combined bending. Because of bending, there will be normal stress in the cross section, and it is also subjected to torsional shear. So the bending stress is, the maximum bending stress is 80 and the maximum shear stress is 80. Okay, now let's try to calculate, my dear students. So let me erase. Okay, now the value of sigma. So if you see, this is nothing but 80 and this is also 80. Okay, fine. So therefore, sigma x is equal to 80, the bending stress. Sigma y, there is no sigma y, 0, and tau is given as 80. He is asking us to calculate according to Tresca theory, if I am not wrong. A second, Tresca theory. Okay, let's calculate the maximum shear stress. Okay, no problem. Sigma 1 is equal to sigma x plus sigma y by 2 plus under root of sigma x minus sigma y by 2 ka whole square plus tau square. Okay, no problem at all. And you know, this is sigma 1 is sigma x is 80 plus 0. 80 plus 0 is 80. 80 plus 0 by 2 plus, if you want sigma 1 to plus or minus 80 minus 0 by 2 ka whole square plus tau is also 80. So I think you are getting sigma 1 comma 2 as 80 by 2 is 40 plus or minus under root 80 by 2 is 40 square plus 80 square. So kitna hoga hai? 6400 plus 1600. This will be under root. So 89 point. So sigma 1 comma 2 is 40 plus or minus 89.44. Okay, no problem at all. Sigma 1 will be plus to 129.44 and sigma 2 will be minus. So 40 minus, so it will be minus 49.44. And I told you very clearly, whenever two principal stresses are of opposite nature, the maximum shear stress will be, absolute maximum will be sigma 1 minus sigma 2 by 2. Whenever, if both are of the same nature, then sigma 1 minus sigma 2 by 2, sigma 1 by 2, sigma 2 by 2. Then from there you have to calculate. But already both are of opposite nature. So the maximum shear stress is given by sigma 1 is 129.44 and sigma 2 is minus 49.44 by 2. If I calculate the maximum shear stress in the actual member, it will be 129. It will be 129.44 plus 89.44. So this will be 129.44 49.44 s by 2, 89.44. This is the maximum shear stress, but this is shear. Let us see what is the I know the maximum shear that we got is 89.44. no problem, it is in megapascal, and the yield stress in tension is 350. So according to Tresca theory, the maximum shear permissible is sigma yield by 2. What is sigma yield? 350 by 2. This will be 175. Now this is the actual working stress. We have calculated this 89.4 from the actual stresses. This is from actual loaded member we have calculated. So this is the maximum working stress in the material, and the maximum permissible is 175. So the factor of safety is nothing but maximum permissible. The maximum permissible is from yield, I get sigma y by 2 as 175 by the working stress. The working we got from the actual loaded conditions as 89.44. So therefore, if you calculate this value I'm getting this as 1.956 or 1 point, if I round it off, 1.96 is the factor of safety according to maximum shear stress theory. Now we'll take up the last question, which is very important. Please take up this question. This is a wonderful question. Let me read the question first. It's a very good question. Let me read the question, and it's a beautiful question. ये ले लेंगे, नहीं तो कलर चेंज करेंगे, कोई दिक्कत नहीं. हाँ, हाइलाइटर, okay. I'll take up light color. ये वाला ले लेंगे. In the structure shown in figure, this is the figure. Bars AB, this is AB, and BC, this is B and this is C, BC, are made of identical material. Both these bars are made of identical material, having circular cross section of 10 mm radii. Of the radius is 10 mm or the diameter is 20 mm. The yield stress is given as 280 megapascal. Using von Mises criterion, the maximum load that can be applied along the Z direction. Z direction is perpendicular to the plane of this screen. This is the Z direction. This is the Z direction that can be applied at C. This is point C, such that AB does not yield. Okay, this is AB. So बोल क्या रहा है? It's something like this, my dear students. Let me explain. Okay, now this is the member. इधर देखना. Yeah. This is the member. Okay, right. Now, observe. We are applying a load like this, perpendicular to the plane, matlab aisa. So what he says is, what should be the maximum value of this load perpendicular to this screen, matlab ye Z direction. How much load should be applied so that this member does not fail according to von Mises or distortion energy theory? This is the question. Now we'll try to solve this question. This is a wonderful question, my dear students. Okay, now, okay, this is our C. Okay, the lengths are given. AB has a length of 0.55 meter or 550 mm. BC has a length of 0.5 meter, that is 500 mm. We are applying a load actually like this. Let the load be P. Very good. Now he is asking no failure of this member AB. So what I do is, from my mechanics, एक second, दूसरा color ले लेंगे, different color. Okay. What I do is, I have applied a load like this. So what I do is, I will apply hypothetical like this, PP. Very good. तो क्या होगा देखो, please observe. This is the actual load. So I am applying at the same point two equal loads of opposite sign. So mechanics से कोई problem नहीं है. And if you observe these two, एक बात देखना. If you observe, I'll change the color again so that you can understand clearly. कौन सा color ले ले? Okay. If you observe these two, this P and this P, one is inwards, one is outwards. So these two are creating torque in the cross. It will create a couple in the cross section of this. ध्यान से सुनो. It's like this. Okay, so now observe here. I have applied a force. Actually, देखो so like this. ये तो already applied. तो मैं क्या कर रहा हूं, इधर एक apply कर रहा हूं, both in the opposite direction. Both in the opposite direction. इधर देखना. Both in the opposite direction. इधर एक. So already we have a load here. तो ये और ये क्या कर रहा है? It is, they are trying to twist this. They are trying to twist this. This, and if you see, this is like this and this is like this. तो ये वाला ऐसा और ये वाला ऐसा. They are creating couple in the cross section of this B. मतलब ये these two will result in a couple that is in the plane of cross section of this AB. तो ये टॉर्क क्रिएट कर रहा है. अगर हम AB को ड्रॉ करके बताएंगे, okay, this and this, these two, inward, outward, so both are causing a torque in this member. So what is that? P into what is the length of BC? The torque is given by applied load P into BC. What is BC? 0.5. तो 0.5 मीटर को मैं क्या करता हूं, 500 mm लेता हूं. Let this be in Newton, this is in mm. So the torque is, the length BC is 500 mm. So therefore P into 500 mm is the torque. Because of this torque, there will be torsional shear stresses. Okay. And please note down, ये दो तो replace हो गए, ये दो, these two got replaced, but there is a load like this. देखो एक बार. And these two got reduced in terms of couple torque, but there is a load like this. देखो एक बार. And there is a load like this. इधर देखना. There is a load like this. Because of this, it will bend. There is a load like this. Yeah. How much P? So he is talking about AB, and the length of AB is 550 mm. Okay. So this is resulting in bending this. And where is the bending moment maximum? 1 second. Where is the bending moment maximum at the fixed end? So maximum bending moment is given by P into 550. So it will be 550 P and the unit is Newton mm. This is the magnitude of bending moment. This is the magnitude of torque. Both are in Newton mm. Because of the bending, there will be direct stresses, that is, bending stresses, which are nothing but normal stresses. And due to torque, there is a torsional shear stress. Let's try to calculate. And M by I is equal to sigma by Y. He's asking P. So let's calculate sigma. What is sigma? My by I. So sigma will be equal to M. What is M? 550 P. Okay, that is M. Y. And it is given the cross section radius. This is the one. So this radius is given as 10 mm. So therefore my Y maximum stress, bending stress, will be here. So therefore Y will be equal to 10 by My by I. I is pi by 64, d power is and diameter is 20. So therefore it will be 20 power 4. Let us check the unit. M is in Newton mm, Y is in mm, and I is pi by 64, d power 4. Diameter is in mm, diameter power 4, mm power 4. So mm square. So it will be Newton per mm square, which is megapascal. So let me calculate. So what do I get? 550 into 640 divided by shift exponent, okay, by 16, 1, 2, 3, 4. This is 0.7. Okay. So the sigma is given by 0.7 P. Now let's calculate the maximum shear stress due to this torque. T is 500 P. The maximum T by J is equal to tau by R, or tau max is given by 16 T by pi d cube. You know it very well. So therefore 16. What is T? कहाँ गया जी? 500 P. So 500 P by pi diameter. What is the diameter? 20 cube. If I am not wrong, एक बार diameter check करेंगे. Let me check that. Yes, 20. No problem at all. So therefore 16 into 500, okay, by pi by 8, 1, 2, 3. 1 second please. 16 into 500 by pi by 8. क्या गलत हो रहा है यार. 16 into 500 by 8. 0.318. Okay. Newton per mm square, which is megapascal. Okay. There is a normal stress of 0.7 p and there is a shear stress of this. It is the case of combined loading. There is a normal stress of 0.7 p and there is a shear stress, already we know, of 0.3183. Anti-clockwise, clockwise. Okay. Okay. Let's calculate sigma 1 comma sigma 2. What are sigma 1 comma sigma 2? This is nothing but sigma x. There is no sigma y. It is 0. So therefore, the principal stress are given by sigma x plus sigma y by 2. Sigma x is 0.7 p plus sigma y by 2 plus or minus under root of sigma x minus sigma y by 2 का whole square plus tau square 0.3183 p का whole square. Okay, no problem at all. No problem at all. 0.3183. There is p also. There is p also. Okay. Now let's calculate square plus 0.35 square. This value is 0.4731 p and this is 0.35 p. Sigma 1 comma 2. Sigma 1 will be plus, sigma 2 will be minus. So plus 0.35. This is 0.8231 p and this is 0.35 minus 0.4731 and this is minus 0.1231 p. He is asking according to distortion theory. I repeat, he is asking according to distortion theory. 1 second please. Sigma 1 is 0.8233 p. Let me check. 0.8231 p and sigma 2 is sigma 2 is minus 0.1231. Very good. He is asking according to distortional energy theory the maximum load. We know according to distortional energy theory. In fact, in my earlier videos on theories of failures, I have derived each and everything. Sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 is equal to sigma y square. Already I had derived. 1 second please. What is the yield stress given? It is 280. It is 280. Sigma 1 0.8231 p का whole square. Sigma 2 minus 0.1231 p का whole square minus sigma 1 0.8231 p into sigma 2 minus 0.1231 p should be equal to sigma y. I think it is given as 280. एक बार फिर से चेक करूंगा. Yeah, 280. No issues. Okay. Now let's calculate this. Don't worry. 1 second, please. Yeah. Yeah. Now, so एक बार I will calculate 0.8231 का स्क्वायर प्लस 1231 स्क्वायर, ओके, प्लस 8231 1231, ओके, तो ये आ रहा है 0.79397 p square is equal to 280 square into, so you are getting the value of p square as 98774.2, and if you want p, so you will get p value as 314.23 Newton. This is the maximum load that we can apply so that the material does not fail, these are some of the good questions which you can expect in your mechanical gate, so or engineering services, whatever it may be, because for machine design the syllabus for gate and engineering services, even word to word, everything is absolutely same. So we can expect such questions in either gate or engineering services. So thank you, my dear students, for watching. So I'll come up with many more such questions. God bless you all. Thank you.